3, 2, 1, 0, and liftoff.
All 3 engines up and burning.
Tranquility Base here. The Eagle has landed.
Sveiki sugrįžę į dar vieną Space and Time epizodą ir kaip visada ačiū, jog klausot ir ačiū, kad mūsų palaikot. Mūsų epizodus galite išgirsti ir pamatyti anksčiau mūsų Contribui platformoje, tad esate visi laukiami prisijungti į mūsų gretas. Na, o šiandien epizodas bus visiškai kitoks. Tiesiai iš už Atlanto mes kalbinam profesorių emeritą Charles Elačį, kuris 15 metų buvo NASA JPL direktorius. Kosmoso pasaulyje Charlesas yra nusipelnęs ir stipriai vertinamas mokslininkas. Jis prisidėjo prie tokių misijų kaip Curiosity, Cassini, Juno. Vienas iš misijų valdymo centrų NASA'je yra pavadintas jo garbei. Iš karto noriu perspėti, jog interviu su Charlesu bus anglų kalba, tai jeigu dėl to iškils kažkokių problemų, labai atsiprašom, o dabar lekiam į epizodą.
Are you ready, Charles?
I'm ready. I'm always ready.
So who started me?
You.
Okay. So the first question is, the last moments before the spacecraft enters another planet's atmosphere or lands on another planet is called, as you know, 5 minutes of horror. It's when everything can either go very wrong, and for example, the spacecraft crashes on another planet, or very well, as it usually happens. What do scientists and engineers do during those last moments?
They are sitting at the edge of their seats, that's for sure. No, that is the most challenging part of any planetary mission. If you go in the early days, the launch was the biggest challenge. People were always nervous. Now launches are almost routine. I mean, it's always still risky, but most routine. Then the next challenge was when we get to a planet, getting in orbit around the planet, firing the rocket after like 6 months or 3 years, depending what planet we're going to. And that we're getting much better at now. So the biggest exciting thing and where the nervousness is when we try to land, particularly on a planet which has an atmosphere, like Mars. It has a thin atmosphere, which means that the atmosphere by itself is not enough to slow us down with a parachute, like on Earth. So we need to use both a parachute and retro rocket and heat shields. So there are lots of things which have to be used to slow us enough. We are arriving with the energy of the equivalent of about 18,000 race car going at full speed. Okay. And you have those 5 minutes to slow yourself down so you can land safely. So there are lots of things which have to happen, and they have to happen exactly at the right time. Heat shield, drop the heat shield, open the parachute, fire the retro rocket, and so on. And all of that has to be done autonomously because there is about 10 minutes time delay between Mars and Earth, so you cannot joystick it. So, so we do a lot of testing, ahead of time. We verify multiple times. But still, there is always that nagging risk. If the computer hiccup happens, then we're in trouble, on doing that. So usually people are very nervous and will be watching, every event happening next, and then you can hear the relief, in the room from the people involved in the parachute or involved in the landing. And no, it is a very tense time, but fortunately, knocking on wood, our last 4 missions, they all worked very well.
Well, you mentioned that you're knocking on the wood. Is there any rituals you do before missions?
Oh, yeah, no, I'm glad you brought that up. We have a ritual which we call the peanuts.
All right, what's that?
And so at JPL, every time before a major event happens, we pass a can of peanuts. So everybody eats some peanuts. That's kind
cool.
of a historic ritual, from the early days of space exploration where we had a number of failures, landing on the moon, like 6 failures. Then the 7th one worked perfect. And nothing changed. And we kept wondering what happened until someone said, oh, we were eating peanuts when that happened.
Okay.
So that became kind of a habit, of doing that.
Yeah.
So you were a leader for a long time. You were the director of the JPL for 15 years, and you were the one who had to talk to the team in case of a failure. What do you usually say? And is it possible to say anything comforting during those moments when people are,
No, that's a very good question. So the key thing, like always when we had landing or encounters, I used to have two speeches. One speech, if things go well, and one if they don't go well. But the key thing is to really prepare the people ahead of time. Because any failure, no matter how ready you are, it's extremely disappointing. So starting many, many, many months ahead of time, or even from the beginning of the mission, I used to always tell people, look, we are in a very risky endeavor. And that's why we explore. Exploration is very risky. All the explorers before us, they had setback, so it doesn't go smoothly because you are doing something for the first time. So be prepared. We are going to do our best, to be successful. Mm-hmm. But be prepared, there could be a setback that could happen. And I was always assuring them, telling them, look, if we are successful, you guys will be on the podium. If it fails, I'm going to be on the podium, describing that. And we do the same for the media. And for everybody we interact with, emphasize to them the risk that we have. As you mentioned about that 5 minutes of terror, if you recall, we had a video which called 5 minutes of terror, which we prepared ahead of time. Oh. And it was basically a series of interviews with the people who were working on Curiosity in that case. And they were explaining how challenging it is and how risky it is. And we put that video on the web. So everybody was seeing it and kind of got appreciation of how challenging it is. So
people got empathetic.
So it kind of prepared, even the media, who are usually very critical, they told us after they saw that video, they were really excited about what we are doing and they were cheering for us. And they said, if you fail, we would understand, because this is very challenging mission. So you need to prepare the public when you are doing this kind of endeavor, to prepare them that this is very challenging, but it's worth it, because it's going to expand our frontier, expand our knowledge. The same way with all the explorers, before us. It was one who did a good job. They really said how challenging their mission is. Recently I was reading about Shackleton, the explosion. I mean, that was a big challenge. And he was celebrated even if he failed, but because of his courage to go and get his crew, save his crew, he was still celebrated on doing that.
Well, how do you think then, which mission has led to the greatest progress in space exploration?
Oh, that's a very good question. I mean, all of them have really contributed tremendously because every mission we are learning something, from it. It opens a new field, or we learn science from it, or we expand our knowledge. So all the missions contribute. It's hard to tell which one contribute most. I mean, thinking back, and it might surprise you, it was one of the missions which were an Earth orbiting mission, which detected that we're losing ozone in the South Pole. Mm-hmm. And because of fluorocarbon for refrigerator, if we did not detect that and be able to monitor it, it could have made a major irreversible impact on our environment. But because of that, then there was activity, and then there was a Montreal Protocol about limiting the emission. So that's an example where space really had a direct impact on our lives. I mean, the other one were all exciting, expand our knowledge, but this one had a direct impact on the survival on our planet.
I'm actually interested in the process of developing and launching a mission. And do you usually have a plan B, C, D, and so on in case plan A doesn't work? For example, something happens just before those last moments of horror before a spacecraft lands on Mars, and something happens, and especially, for example, regarding human flight.
Yeah, well, it's not, we don't call them plan A and P, but we are always having backup options.
Yep.
So we always, on all of these missions, we would say, what if this happens? something bad happens. What is our backup, option? So that's why there is a lot of redundancy in many of our systems, like particularly the human system. So always there are like two computers, that we use. And if one computer had a problem, we switch to the other computer. And in the case of the human, if the second one fails, then the astronauts will take over and do their best to do that. But on all the robotic mission, we have always backup plans. And that's one of the key things we do is to always, the best engineers are the one who keep always thinking, what if this happened? What do I do? What if that happened? What do we do? So for instance, when we do the landing or going in orbit, we always do a simulation, like many months ahead of time, a simulation of training of, going exactly through the sequence. And then we have engineers who go and purpose put some bugs into the computer, into the sequence to see how do we react. How does the team react to it? So they get trained on reacting quickly for some unexpected issues and combined with a lot of testing that we do to verify that things actually work.
During your time at the JPL, have you ever had to implement the backup plan, for example?
Oh, yeah. No, we had in a number of situations where there was some failure. Then typically, usually we focus to make sure everything worked well, like during orbit injection or landing. But after, like when we were driving the rovers, around Mars, a couple of times the rovers got stuck, into the sand dunes. So we had to go back to plan B to figure out how do we unstuck them out of the sand dunes. And part of the way we do it is we have what we call a Mars yard at JPL, where we have an identical rover to the one on Mars. And we try to simulate and put it in the same position as the one on Mars. And then we sit down and figure out how do we get it out. It's like if you are driving your Jeep in a sand dune, you try different kind of things, to unstuck yourself. So that's what we do. And then once one of them works well, then we send the commands to actually exercise that.
Well, I have one question about rovers right now. Advanced technologies are becoming more accessible to ordinary people, and cyber attacks are becoming more intense. Have there been any attempts to break into spacecraft? Theoretically, is it possible to do such things?
Well, that's also, a matter of fact, you asked probably the biggest worry I had when I was director at JPL was that something like this, will happen because it was becoming very common. And yes, there are attempts of cyber attack to our ground systems at JPL, but we have a lot of, firewalls and so on. To get into a spacecraft, the only way you can do that is through the uplink. But that requires huge antennas. So we have antennas which are the size of football field because the distance is so far away and the signal is so weak. So you need very big antennas, on doing that. So that's one, which protect us, a little bit. The other thing we do is we make sure when we send a command to a spacecraft, usually the spacecraft does not execute it. The spacecraft send it back to us and say, is that what you want me to do? And then we verify, then we tell it yes or no. It's a little bit like now what happened when you go and charge on your credit card, you get an email saying, did you do this transaction?
Like a security question, right?
Yeah. So it's similar. It's kind of similar thing, but that is always a concern. But so far it has not happened. And we put a lot of protection. All our commands are sealed out from any internet, kind of activity. Yeah. But there is always a small risk that could happen.
Turiu trumpą pranešimą. Žiūrėkit, jeigu Čarlzas bijojo, kad kažkas gali nuhakinti Curiosity, tai žinokit, rizika, jog kažkas gali užgrobti jūsų kompiuterį ar telefoną yra taip pat didelė. Tačiau nuo to galite apsisaugoti su Surfshark VPN. Surfshark VPN užtikrins saugų ir patikimą naršymą internete. Visa jūsų informacija bus užšifruota, todėl laisvai galėsite jungtis prie viešojo Wi-Fi tinklo. Siųskitės ar siųskite failus užtikrintai, nes Surfshark VPN pavers jūsų lokaciją ir parsisiuntimų istoriją privačią ir užkoduotą. Surfshark automatiškai blokuoja daugiau nei 1 milijoną žinomų kenkėjiškų svetainių, sukčiavimo metodų ir kitų grėsmių. Ir tai dar ne viskas, ką suteikia Surfshark. Tik vieno mygtuko paspaudimu galėsite keliauti po pasaulį, prisijungti prie kitos šalies serverio ir taip laisvai žiūrėti anksčiau neprieinamą turinį YouTube, Netflix ar kitose platformose. Visą parą veikiantis klientų aptarnavimas užtikrins nepriekaištingą Surfshark veikimą, o su mūsų kodu PVS jūs gausite net 83% nuolaidą ir 3 mėnesius nemokamo naudojimo. O jeigu liksite nepatenkinti, visada galite pasinaudoti 30 dienų grąžinimo garantiją. Matot, kaip jumis įvyniau į reklamą.
Regarding the missions, how long does it usually take to prepare for a mission? Because I see a poster behind you from the Cassini mission with the rings of Saturn.
Oh,
and I know that that Cassini mission started, the idea of it started back in the 80s, right? That's right. It ended, the mission ended in 2017. So it lasted for a couple of decades. Voyager mission was launched in 1977, right? And it's still going for decades. And how long does it usually take?
Yeah, well, in our business, you have to be very patient.
Yeah.
And part of the solar system is big. It's the distances.
And we are tiny.
Traveling. So typically it takes for just a trip, just to get there. If in Earth's orbit, it's almost instantaneous, couple of days. If you go all the way to, let's say, as you mentioned, Cassini or toward Saturn, that's 7 years of travel, just to travel to get there. So as you mentioned, on the Cassini mission, we started thinking about it in the 80s. And then it took a while to kind of decide what would make the most sense. And we had to convince NASA. NASA had to convince Congress to provide the funding. Once the funding is received, it takes about, depending on the complexity of the mission, anywhere between 5 and 8 years to actually design and build and get ready to go and launch it. And then depending where we are going, it could take anywhere from a few weeks to many, many, many years. In the case of Mars, it's about 9 months to get to Mars. And then typically, we design our mission to be about 3 to 5 years of operation. But we are very careful in the design of the hardware, so we are sure we can exceed that. And then, like you mentioned, in the case of Voyager, now it has been operating for almost 45 years. Yep. So, once you get in space or once you get in orbit, things are not too dangerous. It's really the getting in the orbit or the landing, and the launch, of course. But once you are in space, we know exactly how to design, to protect from radiation and to protect from the environment. So things would work, once you are in orbit or you are on your way, they tend to work very well and last beyond their lifetime.
If the budget of NASA missions were bigger, would technology progress be faster?
You mean to travel?
Yeah, I mean, like in general, if NASA has like a more like a bigger budget, money isn't like.
Oh, I see. Okay.
Yeah.
Well, of course, when you get more money, you can do more. You cannot go faster, because it's really driven by the technology and by the design.
Yep.
And as I mentioned earlier, we have to be very careful about what's our plan B or what's our backup, and we have to test all of that. So I think things would not go faster, but we can do more, as if you have more funding. Now, on the question of faster, the only way you can move faster if there is any breakthrough in the propulsion technology. The big thing which drives us now is we use chemical propulsion. And we almost are at the limit of what we can do, how fast we can go with chemical propulsion. But people are thinking now about electric propulsion. They are thinking about nuclear propulsion. They are thinking about matter, antimatter. So there are lots of very far out ideas. And if any of these ideas make a breakthrough to give us more power to push, the spacecraft, then that could allow us to go significantly, faster. And that could shorten, the travel. The travel time. But the development, I think in general, maybe you can have a little more people working on it, but it won't be a dramatic change.
Oh, okay.
Talking about ambitions and ambitious missions, I know that one of the missions that you and NASA JPL is currently working on is Europa Clipper. to Jupiter's moon Europa that can probably has water and oceans and geysers and so on. I really like the mission. So can you tell more about the missions to our listeners and viewers?
Yeah, one of the exciting targets in our solar system is Europa, which is a satellite of Jupiter. And the reason it's very exciting is it's about the size of our moon. We know it's made of ice, water ice on the surface, but we also see a lot of fracturing in that ice, similar to what you see when you fly over the North Pole. So because of that, and because of the measurement of the magnetic field, we believe there is an ocean just below that surface and the ice is floating on it. So immediately when you think there might be a water ocean, H2O ocean, and if it's liquid, that means it's relatively warm. And we know there is organic material on Europa. So the immediate question, could there be life which have evolved in that ocean? So that's why Europa is a very important target for us. So now we're building a mission. Matter of fact, it's in the final assembly to be launched 2 years from now in October of 2024. Which on that mission, it goes to Jupiter, orbit Jupiter and Europa. And we have a radar sounder and many other instruments. But the radar sounder will sound the ice and tell us how thick the ice is on a global basis. And then the reason we are interested in it is after that, we're planning a mission where if the ice is thin, like a few hundred meters in some areas, is to put a lander, drill our way through the ice and put a probe or a submarine in the ocean to explore, that ocean. So that's going to be one of the more exciting and challenging missions, drilling through that ice. Remembering you are on a different planet and you are doing drilling similar to what the oil companies do here on Earth. So we don't know exactly how to do it, but that's not unusual. Many of these missions, when we started thinking about them, we didn't know exactly how to do them. So we developed technology, we do testing and so on. And that I'm pretty sure within the next 10 years, we'll be able to do a mission like that.
But interesting how big must the drill be, right? Yeah, because the ice is quite thick, right?
It can be tens of kilometers, right?
It is a lot of technology. So one approach that we're thinking about or being tested is instead of a drill, you put a probe and you put plutonium in the nose of that probe. And as the plutonium decayed, it generates heat. So you melt yourself down.
Oh, okay.
Instead of drill yourself down. But still, there are many problems because as you melt yourself, then it freezes behind you, the ice. And then how do you get that cable, to keep, pulling you down, or how do you communicate? So there are lots of challenging issues, but people are very innovative. They come up with all kinds of innovative ideas.
Yep. But in case we found life, what kind of life we are talking about?
On Europa.
Yeah.
I wish I knew.
What do you think?
What do you think in your mind?
Well, it could be similar to life on Earth. On Earth, we thought that there is no life at the bottom of the ocean because you need sunlight, for biological activity. But it turned out when you go down at the bottom of the ocean, where there are those heat vents coming from volcanic activity, there is all kinds of very exotic life based on the heat generated, not on the sunlight, but on the heat. Which generate. So it would be a great surprise. I hope I can live long enough to see what that life would look like.
Well, Jupiter or Saturn, they are not really habitable for life as we understand it, as we know it. But the moons of Jupiter and Saturn can actually host life as we know it. What happens on these moons that they suddenly become possibly habitable?
Well, that's really the heart of the question is how does life start? How does life evolve? I mean, on our planet, when the Earth was formed, there was no life at the beginning. But then somehow the chemicals got together and they mixed and they led to organic material, which somehow led to cells, which somehow led to you and I having this conversation.
Yeah.
Wow.
So it's amazing how life started. It started from almost nothing, rocks and heat and molecules, and kind of evolved. So the key question is, if by looking at other location, is there a standard rule of how life evolved and therefore it always lead to people like us?
Yep.
Or is there different passes of evolution which could lead to different kind of life? And that's why these moons of Saturn and Jupiter, we think if there is life in their ocean, that means below the ice, that means they are protected from the radiation of Jupiter and Saturn, how would it look like? Or on Mars, if life evolved in the early days of Mars when there was water on the surface of Mars, is it a law that it has to evolve like what happened on Earth? Or is there different branches, in that? I mean, you look at our planet, it's amazing. I mean, I'm always amazed when I go walk in the forest or go hiking and so on, what diversity we have.
Oh, yeah.
Be it in the animal life or vegetable life. It's amazing. And it all started from the same thing, from the same molecules that were on this surface, a few billion years ago. So that's what's fascinating about this.
Well, we asked our listeners to submit some questions. And one of the questions was, let's pretend we found like a life. Is there like a protocol how to approach the new life?
What would scientists do?
Yeah, no, people are thinking about that a lot. Because it will be, and many scientists are thinking about, what would you do? The challenge is we don't know what that life looks like.
Yeah. All right.
So a lot of, forward thinkers, including science fiction kind of people, always thinking about now, the other part of that question is, what would it look like if we detect another star which has planets around it? We find planets similar to our planet. So many people are doing the same thing, thinking of what do we do? And the focus will be mostly on using radio receptions, looking at big antennas, can we detect signal coming from those planets? Because if they are advanced, if it's life similar to ours, they probably have TVs and communication and internet and so on. So that way they are radiating microwave signals. And those signals will propagate and they will get to our planet few light years later. And the question is, can we detect them? And then if you detect them, is there any pattern to them which will indicate they are not natural emission, but they are emission from some kind of civilization? So yeah, there are a number of thoughts. It's a very exciting field to think about that. Of how would you handle it, and what would happen if we find some indication, of life somewhere else.
Okay, if we are visited by an extraterrestrial civilization, let's say, do you think they are going to be friendly to us, having in mind that they visited us, they have technology that is thousands or maybe even millions of years more advanced than us? Also, the civilization meaning is more advanced than us. Would they treat us like we treated other civilizations during colonization era? Or do you think they are more advanced and they are not that violent anymore?
Well, good. You have been watching Star Trek. No, I mean, number one, if any civilization travel here, they must be a very advanced civilization, because to be able to do that, the nearest star to us is about 5 light years away. That means to travel to here, they must have developed some very, very advanced technology way beyond our technology that we have in here. So you would imagine, or at least I hope, being the optimist, that if people are so advanced, they will be smart, and therefore they will do things in a positive way. But it's hard to guess. What would happen.
We can just hope.
If that kind of situation. We face that situation.
So let's go back with the missions. One of the missions was Challenger disaster, and how does the human space flight change?
Sorry, which mission was it?
Challenger, the one which exploded. Exploded, yeah.
Challenger during space.
Shuttle, the shuttle.
The shuttle. So my question is, how has the human space flight changed since that disaster?
Yeah, no, I mean, as you know, we had two disasters, two shuttles, which failed, and there was, fatality, unfortunately, on them. That had really a very dramatic impact because, basically it reflected to us how challenging space exploration is. Because part of the reason that this event happened, part of the reason, not the only reason, is we had a number of successful launches on the shuttle. I don't remember, many dozen launches. So we started thinking, they are becoming like airplanes. We understand all the technology and we understand all the challenges. And then what happened during launch, it was a very, very cold day. And there was rings, which attached different segments of the solid rockets. And they were there to be elastic. So when you launch in the pressure, but they were very cold and they froze. And then there was a leak. And that's what led to the explosion from it. So that was really a big kind of reminder that how challenging these things is. It's not like an airplane. You're really sitting on a big bomb and you're firing that bomb. And you're hoping everything will go in the direction that you are that you have designed it for. So that led to a lot more careful and checking and rechecking, particularly for human mission. The second loss, it was that during launch, a couple of the tiles fell off. They were foam tiles, and they hit the wing of the shuttle and damaged the leading edge of the wing, or some ice which fell down and hit the tiles. And again, people did not think about how much damage that could create, by having at launch at that speed and that energy, to have pieces of ice hitting the foam, which is the shield, the front of the wing. And that we didn't realize that until after it came for entry, and all the heat from the entry actually burned through it and damaged a lot of the electric wiring on that. So that led to being a lot more cautious and more careful. And many of these things are also, you have to be careful when you design your hardware, of make sure you design it in a way where it's very resilient for things of that nature. But it will never be zero risk. It's never be zero risk. I mean, even now, when you take off on an airplane, it's a very, very low risk. But as you know, every once in a while, accidents do happen.
Oh, yeah.
Here we are probably an order of magnitude more risky. So you have to be even more careful.
So which mission to you personally was the biggest victory? Having in mind that every mission has a risk of not happening.
Well, I mean, the highest risk definitely is the Mars landing. Those are the highest risk mission that we undertook, and in the 90s, we had failures. So it's not, it looks now simple. You watch that 5 minutes of terror and everything looks like it worked fine. And we landed, everybody cheers and so on. But we know these things are risky and you learn from these failures. So in the late 90s, actually, we crashed a lander on Mars. We didn't know the reason because it impacted on the other side of Mars. So we didn't have direct communication with it. So, but the key thing is after we investigated and we think we determined the reason. So the key thing, again, like I said earlier about telling the team the risks that we're taking when we explore, but also to tell them that, look, even failure, you can learn from it. By pushing the limit, if you fail and if you see the reason why you failed, you can learn from it so you can do better the next time. And we learned from those failure. And there were many failures earlier in the 1970s, in the early days. That's what led to the peanut routine. In the early days, we did have failures and we did learn.
Peanuts were successful.
So that's fortunately, that's why things are going well. So during my 15 years at JPL, we launched we had 24 missions. They were all successful. One mission had a partial, problem, but we were able to still get all the scientific, data from it.
Can you say which mission was that? That had a partial problem?
It was a mission, it was interesting. It was a mission, we had two missions following each other. We had one mission which went through the tail of a comet and brought sample back. Yeah. Then we had a mission identical to it, which went very close to the sun and collected samples from the solar wind and was coming back to Earth. So the two missions were identical. So on the second one, to get things, done faster and cheaper, we decided to skip some testing, because it's identical to the one which just worked, so we skipped on some of the testing. Well, what happened, unfortunately, is when you come back to Earth, there is an accelerometer. It's like a fuse, similar to the fuse you have at home. And basically, it measures the acceleration. And when it reaches a certain level of acceleration as we're entering the atmosphere, it sends a command to the parachute to open. Well, on the second one, it did not open. So when we did the investigation, it turned out there was an error where the technician put the fuse in reverse. So it did not sense the acceleration. So instead of slowing down, it was speeding up, on it. So it's one of these human mistakes. It's hundreds of pieces of hardware. And if we would have done a test on the second one, we would have caught it, on doing that. So this was an example where we tried to rush things a little bit, cut down on testing. So a lesson learned is,
you never rush.
If it's identical to something else, you test it.
Yeah.
You don't skip any test on doing that. But fortunately, the capsule crashed because the parachute did not open. But it was sturdy enough that we were able to still collect all the science. So it was not completely, dismantled. It was damaged, but not completely lost. So that's why I was saying it's a partial loss. And here on Earth, we were able to take it, clean it, adjust. If it was on Mars, we could not have done that.
Okay. Are there all the calculations done in metric system or imperial? Because I know that NASA before used imperial system to do the calculations, right? And there was some
we use metric system.
Metric system.
Yeah, you are bringing some really exciting memory, but maybe not very good memories. No, that was the one I mentioned to you that in the late 90s, we lost some mission on Mars. And that was on an orbiter to do that. Unfortunately, at NASA, we follow always the metric system. And at JPL, we follow the metric system. So we had a contract with a company to build the propulsion system. But that company was using an imperial system. And when they gave us the characteristic of the engine, they gave them to us in imperial, but our engineer who was copying them from the company file to our navigation file thought they were in metric because the contract said metric.
Okay.
And that's why, we were operating thinking they are metric, and reality, the propulsion power and the thrust were all given to us in imperial. So, these are human mistakes which happen. So we do a lot of checking and rechecking. So like if sometime you watch what's happening in our what we call the high bay when we're assembling spacecraft, Goda visited that, but you can see it on the internet.
Coming back soon.
Yeah, you will see engineers working, and you'll see engineers standing behind them. And you wonder, what are they doing? They are watching to make sure, there is two pair of eyes looking at every test that we are doing. And we record everything, by camera. So if anything happens later, we can go back and view was there any placement error, like, the fuse I was mentioning, or the accelerometer I was mentioning earlier.
That's why I always say that scientists and engineers are humans too. That's why we have to treat them like humans. How you being a human, how do you feel when a mission ends? Because you spend decades working on it, working with it every single day, receiving signals from space, for example, regarding Voyager mission, and then it ends.
Yeah, well, a perfect example is what happened on Cassini.
Yeah,
there were, as you mentioned, we started thinking about it in the 80s, and it ended in 2013 or 14. So some people have spent all their career on it. That's like 33 years, and there were a dozen people who were from the beginning to the end. So for them, this became like member of their family, like their kids or their brother. And here we had to end it. Unfortunately, in the case of Cassini, we had to do a specific event to end it because we didn't want the Cassini spacecraft, which is in orbit, once the fuel is completely expanded, then we cannot control it. And we didn't want it to go and impact, one of the satellites, of like Titan or something. So we had enough fuel at the end, we planned it, so we can crash it in the atmosphere of Saturn and actually burn it, in that atmosphere. So it was kind of like I hate to say it, but a planned death, so it didn't happen suddenly. Mm-hmm. We had to plan it and to end it, and somebody had to send a command effectively to pull the plug from it. But again, we kept the emphasis, because I was director at that time. The key emphasis was, look, just celebrate what it accomplished. Celebrate all the things that it has been done. It's like I tell my two daughters, don't cry when I pass away. I had a great life. I accomplished a great thing. So please don't do a funeral, do a celebration, on what I have accomplished. So it's in the same thing, for these spacecraft, is to really celebrate the accomplishment and the exploration that these spacecraft have done.
And we have one more question from the audience.
Yep.
I think it's a great question because you mentioned your daughters. How would you explain the cosmos to a kid, for example, to a 8-year kid?
Old, yeah.
I know your daughters are not kids, and well, they are not kids anymore. But how would you explain? What would you say?
Well, that's also a very good question, and we shouldn't underestimate how imaginative young kids are. Because, at JPL, every day we used to have tour for young kids, from local schools and so on, different ages, all the way from about 8, 9 years old to teenagers. And every once in a while, I used to go in the tour, with them. And they used to ask the most amazing questions. Let me tell you a couple of examples, and most of them I didn't have an answer. Some questions say, oh, okay, we read about the Big Bang. What was before the Big Bang? I mean, I have no idea what was before the Big Bang. Or how does string theory impact the formation of galaxies?
Wow.
Well, these kids, they read things, and they have this great imagination, and sometimes they catch on it. So sometimes it was very challenging, answering their questions. So usually on the cosmos, I used to tell them, look, go and look on the internet and look at the pictures of all these galaxies that we took from the telescope, like the Hubble, the space telescope. And isn't it amazing how this universe was created? And I'm not going to say that I know there is a God or there is not a God. I don't get into the religion. But somehow there must have been a power which created this universe, which led to that. And things like the James Webb telescope, which hopefully will start getting images in the next months, is going to allow us to see all the way to the formation of the stars and the galaxies. And that's hopefully will allow us to learn the history of how these galaxies form, how did stars form. And if we find life in other location, it might tell us about how life has evolved. So I keep telling them, look, we need smart kids like you guys. So study science, and maybe you can discover or can figure out how the universe has formed or how life, has formed. So it's important to keep the excitement and the imagination of the young kids, because for them, nothing is impossible. I mean, they don't know the limits, of things. So they are always thinking this wild things. And we need more people like that, to have that kind of imagination.
And maybe I have a last question.
What do you think when you look at the night sky?
Well, it's interesting because I just came back from hiking in Death Valley, which is not too far from here. And it's very, very dark there. So my wife and I were sitting down one evening and we're just looking at the sky, and you have all these stars, the Milky Way. And number one, it's fascinating about how this universe has been created. But many times, going back to one of your questions, I sit down and look at the star and say, I wonder if there is somebody there looking at us, looking at the sun and see it as a star. I mean, it's just a sense of wonderment, of what could be somewhere else. And sometimes I do think about science fiction. I say, I wish there is a way which I can be transported to another star, so I can see what's in that star. So yeah, it's a sense of wonder and wonderment, and it's important. You reminded me of a quote that I read recently by, I think, a Mexican poet, which said, "We don't lose our imagination when we get old. We get old because we lose our imagination."
Wow.
So that's kind of, and our sense of adventure, of doing that. So keep your sense of adventure, and then you will stay young forever.
Wow. It's like a quote I read as well some time ago, that exploring the space is like longing, science is like longing for us to better know ourselves. Because, when we explore the space, we actually also explore ourselves because we are made of stardust, right?
That's right.
It's beautiful.
That's what I tell, because, also I tell the kids, that we believe there was a Big Bang and there were particles which was generated. And through all that evolution, they formed stars, and the star exploded, and that's what created planet or something happened. And that's what led to us. So I told them, always, when you look in the morning, you are brushing your teeth and looking in the mirror, say, I'm made of stardust. That will make you cheer up a little bit.
Yeah, it's special. Well, thank you, Charles, for your time. Always inspiring, always motivating. I think it's raining outside actually at the moment, but
Really?
when I get the chance, it's usually raining in Lithuania or it's cloudy.
Yep.
But when I get the chance, I will be looking at the night sky and longing. Yeah.
Well, maybe you should move to Pasadena.
That's what you mentioned before podcast, right?
Yes, actually, I was just saying that since you live in Pasadena and you are based there, I always remember when I was there how beautiful it is, because you have mountains, you have amazing nature, amazing climate as well, and probably tons of starry nights as well. And you can just, I'm definitely coming back,
Let me mention one thing to you. I mean, other than Pasadena, literally you are familiar with the decadal report?
No.
So the decadal is every 10 years.
Yeah.
NASA asks the National Academy of Science to bring the science community in over a year or two to debate what should NASA be doing in the next decade. So we call them decadal reports.
Yeah.
Mm-hmm.
There is one for planetary, one for astrophysics, one for earth science, and one for heliophysics. So in 12 minutes from now, literally 12 minutes, the Academy will be releasing the decadal report for planetary.
Wow.
For what NASA should be doing in the next decade.
Wow.
Okay.
So if you want to know that, so probably, it will be released 12 minutes from now. So in about an hour or 2 hours, go and Google NASA decadal report, and probably it will be online.
Yeah.
So it will tell you what are the missions that the science community is recommending to NASA to do beyond the Clipper and the Mars sample return.
Even beyond that. Wow.
Yeah, because those were defined, 10 years ago.
Yeah.
Mm-hmm.
And NASA is doing them now. So these missions that will be in this decadal, probably there will be the mission which will be due in the late 20s and early 30s.
Wow.
So there is possibility, some people talk about the Uranus orbiter, or there might be a number of, and it's always very secret.
Yeah.
In fact, one of the people on it is my next door faculty member. So I kept asking her, what work? She said, wait 12 more minutes.
So you are probably now excited to end this conversation as well, because you will be reading the report.
That's right.
As well. Thank you, Charles, for your
very
time.
Good. Very nice seeing both
thanks.
of you. Both very nice seeing you.
Yeah, we will
Thank you a
talk
lot.
soon regarding the book. I will come back to you with the news, but thank you. It was
Yeah, it was a pleasure. I was very nervous, but it was a pleasure to speak with you. Thank you.
Well, thank you very much. Thank
Have
you.
a nice day.
Goda is my best PR person.
Well, fingers crossed that I still am. I'm doing my best. I'm doing my
Take
best.
care. Have a
Okay,
good day.
have a nice day.
Thanks.
Bye.
Bye-bye.
Charles. Bye.
Epizodas jau baigėsi ir kaip visada noriu paskatinti jį pasidalinti su savo draugais. Paspauskite like, paspauskite subscribe. Jeigu norite paremti mus, tai lėkite į Contribui. O jeigu patikome mes, tai pasekite mus mūsų socialiniuose tinkluose. O dabar sakome iki.